that this is a combustion reaction. And combustion reactions can be a little difficult to balance. So my hint here, you'll be able to tell that it's combustion because you'll always have oxygen as a reactant, and you'll always have CO2 and H2O as products. So if you ever see something like that, then the quickest way to balance it is to start with carbon, then balance your hydrogen, save oxygen for last. All right, so starting with carbon, I have 2 carbon here. On the right side, I only have 1. So I'm going to change that. I'm going to put a 2. Now I have 2 carbon, 2 carbon. I have 6 hydrogens, and on the right side, I only have 2. So remember, what can we multiply by 2 to get 6? We're going to put a 3. 3 times 2 is 6. Now we're ready to balance oxygen. So on the left side, I have 2 oxygens. On the right side, I have oxygen in 2 different places, so I have to add them together. I have 4 oxygens here. 2 times 2 is 4. And here, 3 times 1 is 3. So I have a total of 7 oxygens. Now the problem is I can't make this equal to 7. The only way I could is if I were to put a decimal in front. 7 divided by 2 is 3.5. But you're never going to see an equation with a decimal. So if you get in a situation like this, where you have an odd number on one side, in this case we have an odd number of oxygens on the right side, we have 7. But on the left side we have an even number. What you have to do is go through and double everything. So in other words, instead of a 2, I'm going to double it and make it a 4. Instead of a 3, I'm going to double it and make it a 6. Instead of 3.5, I'm going to double it and make it 7. And instead of this imaginary 1, I'm going to double it and make it a 2. Now let's go through now and see if all that checks out. Okay, so I have 4 carbon. On the right side, I also have 4 carbon, so that's good. I have 2 times 6, 12 hydrogen. On the right side, 6 times 2 is 12 hydrogen, so that checks out. So the last thing I need to check is oxygen. 7 times 2 is 14. On the right side, 4 times 2 is 8. 6 times 1 is 6. And remember, 6 and 8 are added together to get 14. So this equation is balanced. Now, if that was confusing, you might want to go rewind this video, go back and listen to all that again. But the main thing we did is we realized we could not balance this equation without doubling all of our coefficients. So if you ever have an odd number that needs to be turned into an even number, just double everything. All right, I'm going to work the rest of the ones on the front of this sheet with you, and then I'll let you do the back of this on your own. So starting with number 4, we'll look at lead, and I'm going to start doing this now without writing the numbers underneath. I'm just going to go through and only write the coefficients. So 1 lead, 1 lead. For this, see I have nitrate. Nitrate is a polyatomic ion, but I don't have nitrate again on the right side. I don't have NO3. So I'm going to treat this as nitrogen by itself. Since it's in parentheses with a 2 on the outside, I have 2 nitrogen. And on the right side, I only have 1 nitrogen. So I'm going to put a 2 in front. Now I need to look at oxygen. I have 3 times 2, 6 oxygen here. On the right side, I have 1 plus 4 plus 2. So 1 plus 4 is 5 plus 2 is 7. Well, that's not going to work. I have 6 on the right, 7 on the left. So remember what we said about odd numbers? You need to make them even. Which of these oxygens is making this an odd number? It's not this one. There's 4. It's not this one. It's this one. This one by itself is making this an odd number. So I'm going to double it. I'm going to put a 2 in front. When I put that 2 in front, that gave me 2 leads. So I'm going to put a 2 in front of this lead. Now remember what we did with nitrogen earlier. 2 in front of lead times the 2 we already have gives us 4 nitrogens. So we got to go back and fix this. And now let's check oxygen. We had 6 oxygens, but now we have 12. 2 times 6 is 12. Right here we have 2 plus 8 plus 2. So we have 12 on the right side. So notice these last 2 problems, we've had to, reevaluate, do some erasing. That's going to happen. So don't get discouraged if your first few that you do, you have to do some erasing. Just don't do these in pen. Do them with a pencil. All right, 3 more. For this next problem, you might recognize it. It's actually one from the slide. 1 magnesium, 1 hydrogen, 2 hydrogens. So I need to fix that. Now I have 2 hydrogens, 2 chlorines, 2 chlorines, and I'm done. So that really wasn't that bad. All right, number 2. Starting with hydrogen, I have 3 here. I have 2 here. That's not going to work. So what's the first number that 3 and 2 both go into? 6. So if I put a 2 here and a 3 here, that gives me 6 hydrogens on both sides. That also gives me 2 arsenic, and I have 2 arsenic, so that's okay. I have 2 times 4, so 8 oxygen. And on the right side, I have 5 plus 3. So I have 8 on the right side as well. So that is now balanced. All right, last problem that I'm going to do with you on this sheet is number 3. And I'll go ahead and tell you this one is a little bit of a doozy. So let's look at it and you'll see why. Starting with iron, I see I have 2 and only 1 here, so I'll fix that. I have 3 oxygens plus 1, so I have a total of 4. So I'm going to put a 2 here to make that 4. But now that gives me 2 carbon, and I only have 1 carbon. So notice the pickle we're getting ourselves into, because if I put a 2 in front of carbon, now my oxygens are messed up. Now I have 5 oxygens and 4 on this side. So to save you some time, normally what I see students do is they'll immediately start doubling it. They'll turn it from 2 to 4, and then that doesn't work. So they'll go from 4 to 6 or 6 to 8. And I want to encourage you to keep it as simple as possible. If 2 doesn't work, don't immediately jump to 4. Try 3 instead. So instead of a 2 in front of this carbon, let's see what happens when we put a 3. If we put a 3 there, then we also have to put a 3 in front of this carbon. So that's 3 carbon, 3 carbon, 2 iron, 2 iron. Let's look at our oxygens. 3 plus 3 is 6, and on the right side, 3 times 2 is 6. So what could have been a very frustratingly long problem was not that bad once we kept it simple. All right, so I did that side with you. I want you to do the rest of this sheet on your own. Try these without looking at the key, and then if you just get really frustrated and can't do any more, then check your answers using the key that's on Google Classroom. Now I'm going to flip over to this sheet. This is your word equation sheet. And this is also one that you will need to complete by Friday. Just the front of it, though. You'll do the back of it on Monday. So what we're doing here is we're turning these word equations into balanced equations. So what you need to do first is take a few notes at the top. Diatomic molecules. So there are 7 molecules, 7 different elements that cannot exist by themselves. And they are as follows: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So like I said, these elements cannot be by themselves. If they're not paired with another element, they have to come in pairs. They also, this might be helpful in memorization, they form the shape of a 7 on the periodic table. So if you're looking at your periodic table, you'll notice that nitrogen through fluorine and then down to iodine forms the shape of a 7. And then you also have to include hydrogen. And there are a total of 7 of them. All right, we're going to need to keep that in mind for the rest of this sheet. So starting with number 1, zinc and lead 2 nitrate react to form zinc nitrate and lead. Okay, so starting with zinc, Zn, and is our plus sign. Lead 2 nitrate, Pb. Remember, nitrate is NO3. And you have to look at charges. So lead is +2, nitrate is -1, so we have to cross our 2 and put parentheses. React to form, that's your arrow, zinc. Zinc has a +2 charge, nitrate is -1, so same thing, you have to cross your 2 onto nitrate. And is your plus sign, lead. So that is how you convert a word equation into a skeletal equation. And now we just need to make sure that it's balanced. We have 1 zinc, 1 zinc, 1 lead, 1 lead, 2 nitrates, 2 nitrates. So we're finished with that one. All right, moving on to number 2. Aluminum bromide. Remember, aluminum is +3. Bromide is -1, so we've got to cross our 3. And chlorine gas. Now remember what I told you about chlorine? It cannot be by itself. So we're going to have to put a little subscript of 2 next to it. React to form, that's your arrow, aluminum chloride. So again, +3, -1, you got to cross your 3. And bromine gas. Bromine is the same as chlorine. It has to come in pairs. So now we just need to balance the equation. We have 1 aluminum, 3 bromine, 2 bromine. So let's fix that. I want them to be equal. So the first number that 3 and 2 will go into is 6. So I'll put a 2 here, a 3 here, and you might have noticed putting that 2 there gives me 2 aluminums. 2 times 3 gives me 6 chlorines, and then I have to go back and put a 3 here as well. Now, I would like you to try the rest of this on your own. The only thing I want to point out are some of the acids on this sheet because I didn't teach you how to name or write formulas for acids. So going down to number 5, when you get to hydrochloric acid, that is HCl. When you get down to number 6, phosphoric acid is H3PO4. When you get down to number 7, sulfuric acid is H2SO4. And I believe that is it. So you have the key to this sheet. So after you try the rest of these on your own, check your answers. and let me know if you have any questions.